This is Ning from Inter-China Aspect Design Center. So I'm leading the development of the intermediate software. So today, my presentation is about the delivery cost control in our continuous software development. So as we all know, the delivery cost of modern platform software increase rapidly as it usually needs to align with many hardware and IPs, silicons, their TTM, and the feature evolvement, and as well as maybe it will need to be supported by even hundreds of developers, maybe cross-geo. So all those kind of factors make our software delivery cost increase rapidly. So in this presentation, I will leverage our experience in media software development to share our experience on delivery cost control in continuous software development. So basically, it will be composed of 3 chapters. First one is about the hotspots in our development. Then we'll talk about the root causes. And finally, we will share our experience on the corresponding design enhancements. So firstly, I think in last session, so the chairman also asked the question about the intermediate software. So in this presentation, I would like to start from the brief introduction about our intermediate software. Actually, this is a software stack to bridge the Intel GPU and CPU. So it is composed of several layers of softwares. At the top is SDK, then GPU runtime, then user mode driver. Then finally, we also need to include the EU former hard kernel. So in total, the intermediate software is composed of 3 billion lines of code and supported by over 300 developers. I would say it is an ultra large scale software. So in the daily development of this software, actually, we need to face with the challenge from 3 perspectives. First one is the hardware complexity. So currently we need support over 50 hardware IP cores and over 20 SoCs. Second perspective is the complexity from the OS and API. Now we need support 4 different OSs and 4 different APIs. Then the third is about the usage complexity. Now in our portfolio, there are over 200 user-specific configs. All those configs, they will be connected to some specific usages. But finally, they need to be reflected in our source code. So all those kind of complexity will lead to the delivery cost increase in our software development. So those kind of software delivery cost will be mainly reflected by 4 perspectives. First one is the predictable software evolvement. Second is the streamlined parallel development. Third is the continuous integration and the continuous delivery. Finally, it is a customized software release. So in the following pages, I will have some detailed introduction about them one by one. So as the first, so what's the top challenges for our software development? So I think it is our development predictability. So I would like to use 2 diagrams to show what's the difference between the predictable software development and unpredictable software development. So at the left side is the case of unpredictable software development. So I think the key characteristics is actually you can find the product KPIs keep lagging throughout the phases. And we will have rush and high-risk code changes in final weeks. Well, at the right side, you can see it is a predictable software development. It is reflected by consistently early forward progress on product KPIs, and we will see only few required code changes in final weeks of each phase. So of course, if we can have our software development to be predictable, it will greatly shrink our software development cost. Yeah, also because in our ultra large scale software development, usually what you need to face with is not only one project, it's not one product, but maybe tens or even dozens of different products. All those products development, they have some maybe mutual impact. Counting them together, so finally, it will make your project delivery to be a disaster. You will find you are trying to do firefight, trying to be a firefighter to put off the fire in all of your projects. So all those kind of things, it requires some maybe code enhancement, design enhancement in our code. So it requires better code effort reusing between software modules of different dimensions for SOCs, for different IPs, for different features, for different OS APIs, and for different usages. So this is about the predictability, the first factor. Then the second challenge is from the streamlined parallel development. What is parallel development? So actually, I think in our modern software development, usually engineering team need to face with the challenge of parallel development on different code paths. So in our case, actually, because for intermediate software, we commit to open source our software, but it does not mean we will open source all of our source code. Actually, I would say only part of our source code will be open sourced and open for contributions from community. Well, the remaining part, if they are related to the maybe unpublished IPs, then definitely it will keep closed source and only be visible to internal developers. So in that case, as we can find, we need to fight with parallel development on two separate code paths. What does it mean? It will mean maybe duplicate maintenance effort, duplicate maybe code change preparation, duplicate effort on the static analysis, duplicate effort on URT, on code review, and on validation. So in that case, it requires a streamlined development on top of single code base. Basically, it means we want to use one code base to maintain the code for open and embargo simultaneously. And the open source code, because they are just a subset of the closed source code, they will be easily generated, auto-generated from the closed source code. And also for all those kind of maybe daily development work, so the patches on our closed source code will be automatically converted to the patches on the open source code. So this is what we call streamlined dev model on top of single code base. So definitely, this kind of enhancement, it requires the change and the design support. So the third fact is about the continuous integration and the continuous delivery. So actually, continuous integration, it is a software engineering approach to promise our software is ready to be released at any time. In the execution, it means for each commit, it will trigger some automatic build and validation to promise the quality of the commit. I think the key of the CI/CD is something like we need to use maybe shortest time to promise the quality of each commit. So yeah, for our cases, this is the biggest challenge to us because, as you know, we are the source code of the media software is about 3 million lines of code, And to build this kind of software, it requires around 1 hour, so 1.5 hour actually. So yeah, for every day, actually, we have around 15 commits. If each commit, it will take 1.5 hours to build, and the other 2 hours to do the validation. Then I think it will be very hard to apply the sufficient validation coverage for each commit. So it will greatly impact the efficiency of our CI/CD. So I think, to me, the most important or the key factor of the efficient CI/CD is to use the maybe quick enough develop feedback loop. In our cases, we want to maybe apply the CI build acceleration against the modular build, as well as CI validation acceleration against smart validation. This is basically, we want to break the big software module, software boundaries into small pieces, into different software modules. And for those kind of modules, we can build them in parallel so that it can shrink the build time. This is what we call the modular build. And for smart validation, it is something like we can build the traceability from our source code to the features, to the test cases. And in our CI, we can easily deduce the impacted features from the code change itself, and then apply the just enough test or validation coverage. So it can greatly shrink our maybe CI validation and the build time. So yeah, but all those kind of things actually, they are not just some maybe validation build, those kind of initiative. All those kind of things, it requires design support. So in our cases, so because as I mentioned, this is our intermediate software is a complex platform software. It needs to support different IP, different SOC, different OS and API. So here, so as you can see, so we have the decoupling from different dimensions. So firstly, at the center of this diagram, we will have maybe more than 85% of our logic to be shared between different API and OS. So then inside this big OS agnostic part, we will have some domain-specific abstraction. This is to say, this is mainly related to the maybe codec-specific, media-specific config. It is an industry standard related. And also we have some IP abstraction. This is mainly related to our interspecific hardware interface. And also we have the usage abstractions. This is mainly to maintain all kinds of configures corresponding to each specific usage. And also for the SOC, because SOC is just something like to be a castle built on top of the IP built on top of different IPs. So actually here we have one SOC abstraction. It maintains all kinds of recipes of different SOC based on IPs. So in that case, so actually we can easily apply the aforementioned different maybe initiative. We can easily support them. So yeah. So I think at last, I would like to summarize the presentation, the points in this presentation. So first one, the software complexity leads to software delivery cost increase. And also, we find the hotspots in our continuous software delivery. They are the predictable software involvement, streamlined parallel development, continuous integration and delivery, as well as a customized software offering. So we want to use enhanced design for better code and effort reusing.